Okay, I think we're gonna get started. It is quite hot inside, so please, we will try to get the air conditioning working. Hopefully, it will be soon. So it is my pleasure to introduce you to Eugenie Mas. Right?
Yes.
Eugenie is here working with Alberto and Yuna as well, I think, as a visitor. But she's a PhD student at the School of Architecture, Civil and Environmental Engineering, and at the Swiss Federal Institute for Forest in Switzerland.
Yes.
Although she's French, as you will. So thank you very much for offering to come and tell us your work, and please.
Okay. So, hello everyone. Thank you for joining me today. So I will present my PhD project, which is about the impact of tree species interaction on tree-water relation under a warmer and drier climate. I'm doing my PhD with Charlotte Grocio and Fernando Valadares. And before to go in details in my PhD, I will set the context of my PhD. So I will surprise no one when I say that the temperatures are increasing, and indeed during the last century, the temperature increased by 1 degree, and the models predict an increase up to 5 degrees for the coming century. But within an association with these increasing temperatures, some decrease of the soil moisture are expected for the Mediterranean area. And this association of hot temperatures and drier conditions will highly impact a natural ecosystem like forest. With, for example, this combined hot temperature and drier condition has already been linked with a decrease of the wood productivity, more tree mortality, and an increase of fire occurrence. And all these impacts are linked to the water use and water transport. So the plant water transport. So the water goes from the roots to the leaf along a gradient of water potential, a gradient of tension. So the water is taken by the roots, transport in the wood into the xylem. The xylem is composed of two specific cells, the tracheate for the coniferous and the vessel for the broadleaf. And at the leaf-atmosphere interface, the water evaporates through the stomata that is poured at the surface of the leaf with a phenomenon called transpiration. So for the plant, it's essential to have a continuous water transport uninterrupted in order to keep the plant growing and to keep the functional process functioning, like a photosynthesis. But when the condition in the soil become drier, there is less water available in the soil, and the water potential in the soil decrease. So there is less water taken by the roots, less water transport in the wood, and potentially less water will evaporate through the leaf. In response to this steeper water potential gradient, the plant can close their stomata to avoid to lose any water, but at the expense to not taking carbon. Or the plant can decide to keep the stomata open, but at the risk of hydraulic failure, with a process of embolism. Hydraulic embolism are a rapid breakdown of the water columns, and this happens when a vessel full of water and functioning will, under a high pressure, have the cavitation event, which is a bubble of air that appears in the vessel and will expand and fully fill the vessel of air. The vessel is so not functional for water anymore. And as you can see in this picture of a van where a vessel is full of air. So, but a plant can adjust its functional traits in order to keep optimal performance under more restrictive conditions. For example, this is the phenotypic plasticity, and this could happen in a short or long-term period. For example, in the minutes, as I said before, the plant can close its stomata. So for example, at the hottest hour of the day, the water flow of the plant decreases. Or within a season, a plant can shift its water uptake depth to deeper layers in the soil with the dimorphic root system. Or from year to year, the plant can produce smaller vessels in order to reduce the risk of cavitation and embolism, but at the price of reducing the water flow in the root. So, but in a natural ecosystem, the plant is not alone, but interacts with other individuals from the same species or from different species. And this interaction can modulate the degree of stress experienced by the ecosystem. Indeed, several studies have already shown some positive effect of biodiversity and tree species diversity on, for example, the productivity, or by decreasing the defoliation due to herbivory or increasing the multifunctionality of the ecosystem. But other studies also shown some negative or neutral effect of the biodiversity, with, for example, no effect of an increasing species richness to the drought resistance of hemiboreal ecosystem. So in the field of biodiversity, there is some mixed results on the effect of tree species interaction on ecosystem. The tree interaction could be different, could be negative or positive. For example, it can be negative with a competition when two individuals share the same resource and will compete for this resource. But it can be also positive with a niche partitioning when two individuals use different resources. So for example, we take water at different layers in the soil. Or facilitation when one individual with a deeper root system, for example, will take water at deeper layers in the soil and release the water in the superficial layers of the soil, and so increase the general moisture of the soil. So in this context, my PhD is about the interaction between tree species, and all this interaction between tree species modulates the hydraulic trait to a warmer and drier climate. I have two main chapters in my PhD, and the first one is a climatic manipulation of a drought treatment and a heating treatment acting alone on a tree or acting together on the tree. And the goal is to disentangle the interactive effect of heating and drought. So with the main hypothesis that hot drought should exacerbate the response of the tree to a stress acting alone. And this climatic manipulation is applied to different tree mixtures, so to a single tree, to a tree in association with the same species, or a tree in association with a different species, in order to investigate all the species interaction, modulate this plasticity in tree-water relation, and the response of the tree to the climatic treatment. And with the main hypothesis that the species interaction should reduce the stress experienced by the trees. So in order to measure this, I measure different physiological traits. So first of all, at the leaf level, I do some pressure volume curves. That is a measurement that gives several parameters in the leaf and the mechanism of the leaf in the water use. And I will measure water potential at pre-dawn and midday that inform on the hydraulic stress and on the water strategy of the plant. At the leaf level also, I measure some gas exchange measurement with the stomatal conductance, which is the flow of water coming out from the stomata, and the minimum stomatal conductance, which is the flow of water that the leaf loses when the stomata are closed. And at the root level, I measure the hydraulic conductivity, so the flow of water in the xylem, and the vessel diameter and density. So this experiment takes place in the Model Ecosystem Facility, MODEC in short, in the WSL in Bermensdorf, near Zurich. It's composed of 16 open-top chambers with 4 different climatic treatments. So we have 4 chambers with a controlled treatment, water at fill capacity and ambient air temperature. 4 chambers with a drought treatment, a decrease by 75% of the irrigation, but ambient air temperature. 4 chambers with a heating treatment, water at fill capacity, and an increase by 5 degrees of the air temperature compared to the controlled chamber. And finally, 4 chambers with a hot drought treatment, which is a combination of both drought and heating. And within each open-top chamber, 2 tree seedling species were planted in 2018, Fagus sylvatica and Quercus pubescens. These 2 species were planted in different mixture, so in single tree alone, or in an association with the same species, in monoculture, or in a mixture with the other species. And the treatment started in 2019, and during the 3 following years, I measured different physiological traits at the end of the growing season. So I already measured for 2 years, and I still have this year to do. So now I will present to you one of my main results. Here you can see the water potential at Togolus Point for the year 2020 and 2021. So the 2 years are compiled and only 1 are put together. And for all the species mixture, because the statistics test didn't show any species interaction effect. And you can see the water potential at Togolus Point, which represent the hydraulic stress at when the leaf lose their turgor and cannot do any physiological function. And you can see this water potential at Togolus Point for the 4 treatments: controlled, drought, heating, hot drought, and for the 2 species, beech and oaks. So what we can first see is that for the oak trees, there is no significant difference between the climatic treatments, but it's interesting to notice that the tendency is similar to the beech tree. However, for the beech tree, we can see a significant effect with a higher water potential at Togolus Point for the trees under drought and hot drought compared to the control. So what is mean is that the leaf under drought and hot drought treatment will lose their turgor at a less hydraulic stress, at a less strong hydraulic stress than the control. They are more sensitive to drought and hot drought. So this is a little bit surprising because it's a long-term experiment, so we expect acclimation. But if there was acclimation, we should expect that under drought and hot drought treatment, the leaf should be able to handle more stress, more hydraulic stress, so have a lower water potential at Togolus Point than the control. But it's not the case. So what we can say is that it's no long-term acclimation of the leaf of beech trees to drought and hot drought treatment. So the main conclusion I can draw for my first chapter is first, there is no effect of species interaction yet. So this is a little bit surprising, but not so much, because species interaction take long time to be installed and to see effects. So I hope for the coming years I will maybe start to see some significant effect. Then overall, there is few or no effect of heating treatment on the hydraulic traits for the both species. Then the beech trees show a higher sensitivity to the climatic treatment. This is not so surprising because beech trees are more drought sensitive than the oak trees. The oak trees is more drought resistant. And finally, the beech trees show some dynamic response to drought and hot drought, but no long-term acclimation. And then I would like just quickly to show you this first paper that came on the MODEC data. If you are interested to learn more about this experiment, it's a paper that just came out a few months ago, and that presents that warming may extend the tree growing season and compensate for reduced carbon uptake during dry periods. So I invite you to check this paper if you are interested. So now let's move on to the chapter 2, where I study I do some observation on natural and mature forests, where I look the water dynamic in above ground and below ground compartments in a seasonal plasticity. So I measure different water related traits in spring when the conditions are optimal, the temperature is perfect, there is a lot of water in the soil. In the middle of summer, when the temperature increases and the soil moisture decreases. And in fall, when the first rain replenishes the soil, so the soil moisture increases again and the temperature decreases. And I study this trait in monoculture and in higher species richness forest to see all the species interaction can modulate this seasonal plasticity. To be consistent with the chapter, and my main hypothesis is that the species interaction should reduce the seasonal plasticity that I will observe for the hydraulic traits. And to be consistent with the chapter 1, I measure quite similar hydraulic traits. So at the leaf level, I measure again the stomatal conductance and the water potential at pre-dawn and midday. At the wood level, Luna and Alberto measure the hydraulic conductivity, and I will measure the conduit diameter and density. And my main measurement is the measure of water uptake depth using a dual stable isotope method. And this observation takes place in the Alto Taro Natural Park, that is a natural park near Madrid in Spain. It's a Mediterranean mixed forest where I study 4 species that are common to this area, 2 coniferous, Pinus nigra and Pinus sylvestris, and 2 broadleaf, Quercus vaginea and Quercus ilex. Quercus vaginea is the only deciduous species of these 4 species. And this Alto Taro Natural Park is subject to a drought, summer drought every year. So I select different plots with different species richness. So I select plots with monoculture, where there is only 1 species present, plots with 2 species mixture, and with all the different kind of combination of the species mixture, and plot with the 4 species. And within each of these species mixture plot, the relative abundance of the species involved in the mixture are kept similar. And for the non-target species, the relative abundance was kept below 5% of the total basal area of the plot. Within each plot, I select 5 trees per target species, and I have 3 plots per species mixture and species combination, leading to a total of 30 plots. And I did the already measurement last year at the beginning, middle, and end of the growing season, and I do it again this year. So now I will show you some of my results of last year. So here it's a result that show the seasonal plasticity of the stomatal conductance per species campaign, beginning, middle, and end of the growing season, and by species richness, the color denotes the species richness. And so, what we can see first is that there is for every species a nice seasonal plasticity with a decrease of the stomatal conductance in the middle of summer and an increase in fall when the first rain replenishes the soil and the soil moisture increase again. So the plant recovers from the summer drought in fall. And concerning the effect of the 3 species interaction, what we can see is that in spring or in summer, there is not so much difference between 3 species richness, but in fall, when the plant recovers, it seems that for every species, in monoculture, the plant recovers better than in the highest species richness. So this is quite interesting. And the second result I would like to show you, it's the water uptake depth. in the plot with the 4 mixture, with the 4 species, for the 3 campaigns. So from the spring, summer, and fall, for the 4 species, Pinus nigra, Pinus sylvestris, Quercus faginea, and Quercus silex. And here you can see it's a stable isotope of the oxygen that is an proxy of the soil depth. With from 0 to 10 centimeter, 10 to 20, 20 to 30, plus 30 centimeter, and the water source, that is the rains that go in the cracks of the rocks. And what we can see is that in spring, it seems that all the species tend to take the water at the same layers in the soil, quite superficial layers, except for the Pinus nigra. But the most interesting is that in summer, there is a shift for the broadleaf species, Quercus faginea and Quercus silex, that take water at deeper layers in the soil that could lead to a resource partitioning, a niche partitioning of water under the summer drought. And in fall, again, all the plants seems to take the water at the same layers in the soil when the soil is full of water. So we arrive to the end of to the first conclusion of this chapter. So what I can say is that the trees in monoculture seems to recover better than the trees in interaction with other species. Oh, sorry. What do I do? Yeah. And the broadleaf species shift their water uptake depth in summer, leading to a resource partitioning. But I would like to just highlight that the precipitation in summer 2021 was higher than the average of the 10 previous years. So this could result in not so restrictive condition, not so drought, and maybe this could explain this mixed results that I observe. So I hope that this year a drought more intense could clarify the question and the result. Okay, so thank you for your attention, and if you have any question or suggestion, point to discuss, I'm open to question. Thank you.
Well, thank you very much, Adeline. Someone has questions here?
Yeah.
Regarding the chapter 1, why did you choose Fagus and Purpose Rover? Because they are kind of different interaction in nature, so they usually have different niche.
Well, these species were selected for several reasons. First reason is that beech trees and so Fagus sylvatica and Quercus pubescens, it's not rubber, it's pubescent, are different hydraulic strategy. The beech trees are isohydric and the oak are anisohydric, so it means that the Fagus will close its stomata as soon as the stress happens, and the oak have more tendency to leave the stomata open for a longer time at the risk of having hydraulics failure. So it's two different strategies. So it's interesting to see this effect on the two species. And also after why this specific species, it was because actually this project, MODEC, it's a huge project with a lot of PhD involved and project involved inside. And the first PhD that started with this project was also studying some natural forest in France where the mixture of these two species was involved. So it was also a selection of these two species in order to correlate with the natural observation of this PhD. And so it's why they select it.
Regarding routing strategy, they have also differences in the field, I mean?
You mean between Fagus and Quercus?
Yeah.
don't really know, but I think I will be tendency to say Quercus maybe have deeper roots, but I'm not sure 100% about this. And the thing is also that as the MODEC is built, we cannot really test on below ground because it's planting, it's like large pots. It's not really a pot, but I mean the soil, it's deep of maybe 1 meter or 50 centimeter, and it's now allowed like the niche partitioning of roots, so we cannot really test this competition at the below ground level between the species interaction.
I think this thing can be happening and can be the reason that you are not seeing plant-plant interaction? Yeah,
it's one of the reasons. It's this reason, and also that the trees are small, so like the canopy don't really interact together, and also that all this interaction takes always times, and but it's one of the reasons that we think maybe can.
Yeah, and also because they take time, the interactions, but when you leave them develop completely, not fully develop, so it can be also.
Yeah, we really would like to dig out the plant and see what's happening below ground, but we cannot because, as I said, a lot of PhD are involved in this, so if we start digging out a plant, they will not be happy.
Yeah. When you thanked first for your presentation, nice work, when you speak about phenotypic plasticity, are you speaking about temporality all the time? No, you are taking into account the time to see the plasticity. Or
you mean during my after the experiment I've taken?
Yeah.
Well, no, it was more like an example of the different things that can happen. But yes, for example, when I measure the gas exchange at the leaf, I expect more phenotypic plasticity will be like in the minutes, like if they close or not the stomata. But when I do the wood anatomy, it's more to see the phenotypic plasticity from years to years, like the long-term acclimation. So it's a little bit everything I want to see.
Inside of the blood, because you have several blood to compare different condition, integration, no? Maybe you can see the difference of the coefficient of variation between trees and intra-trees. Maybe, and it's another way to see the plasticity inside of the seasons.
It's a good.
The last one, you had any idea why the monoculture recovered better regarding the second chapter?
Yeah, actually, it's a little bit disappointing because my hypothesis is that species interaction should be better, like a more diverse forest is better. Yeah. But some previous studies that was exactly in the same plot that I did, because my plot in Alto Taro are part of the Fundiv exploratory platform. That is a platform of European platform with different plots everywhere in the world, in Europe. And several years ago, one PhD student did some studies and shows that under a good condition, like when there is no drought, monoculture perform better. But under drought, it's a species interaction perform better, mixture perform better. In terms of wood productivity, he was studying wood productivity, more productivity when the conditions are good, and so it's why I said that we have to think about like the spring was very wet this year, last year, and maybe it can make this. So I hope that this year it will be very dry and terrible condition. Yeah, it's my layer of sample for both MODEC and Alto Taro.
Because we had a lot of rain this year as well.
Yeah, I know, but surprising, the campaign I did last week, 2 weeks, I don't remember. Yeah. the first, so the spring sample, the first plot we did was extremely dry like the summer drought we have last year. So
In land it was less rainy than here in the coast.
but the thing is, last year it was not so raining during the winter, but the problem is the month of June was super raining in Alto Taro, and I think it's why it's after the summer was not so dry, because the month of June was super humid. So maybe if this year the month of June is super dry, yeah, I hope.
Yeah, it's probably going to be like that because it's been raining before and now we don't
Yeah.
expect much rain. So hopefully for you, that's going to be it's going to be too high.
Yeah, I really hope so.
Someone has more questions here? And what about the chat? Yes, I'm sorry. No, not in the chat.
Okay.
Well, okay, thank you very much again, Jenny, for coming and telling us your interesting study. And hope you get a lot of dryness.
Yeah, and hot temperatures.
So
Yeah.
you can compare it.
I want the craziest canicule, like a very like heat wave, like
Yes.
never spend live in their
No,
life.
not
Like
that much. Be blessed. Thank you very much.
yeah.